Okay. Come Hi guys, welcome to our YouTube channel, Just Do Maths. Today we're going to look at Calculus 1, undergraduate level. The topic that we're going to look at is proof by contradiction. So I'm going to explain how the proof by contradiction really works, but I'm going to explain this by means of an example. So here's the example. Prove that root 2 is irrational. Prove that root 2 is irrational. Right. For us to prove that root 2 is irrational, we have to prove this using the contradiction technique. So in this case, suppose the square root of 2 is rational. Suppose the square root of 2 is rational. Remember, a rational number can be written in the form a over b, where a and b are integers, but b must not be equal to 0. So the square root of 2 is equivalent to a over b. We have assumed that square root of 2 is a rational number. Right, from this stage, if we square both sides, we can get that 2 is equivalent to a squared over b squared. Right, if we multiply both sides by b squared, we can get that 2b squared is equivalent to a squared. Right, so in this case, 2b squared is equivalent to a squared. Right, 2b squared is an even number. 2b squared is an even number. We know that if we multiply any number with a 2, we can get an even number. So 2b squared is an even number. Yet we are saying 2b squared is equivalent to a squared. So if 2b squared is an even number, then a squared is also an even number. Is also even. So 2b squared is an even number, and a squared is also an even number. Alright, so if a squared is an even number, we have said that a, remember we said a, we have said that here in this case that a and b are integers. So remember I said the a and b are integers, and an integer can be even, and an integer can also be odd. So if a squared is an even number, then what is the value of a? We can only get an even number if we square an even number. For example, if I say 1 squared, I can get 1. If I say 2 squared, I can get 4, and 4 is an even number. 4 squared, 16 is an even number. 6 squared, 36 is an even number. So a squared, if a is even, a squared is also even. But if a is odd, a squared is not going to be an even number. So if a squared is even, then a is also even. Then a is even. Right. So if a is even, we know that any even number can be written as 2 times any number. So if a is even, then a is equivalent to 2, say 2k. So a is equivalent to 2k. Right. Let us replace this value of a into the original equation. This will give us 2b squared is equivalent to a squared. And we know that a is equivalent to 2k, which is an even. We conclude that a squared is even here. So a is equivalent to 2k. So 2b squared is equivalent to 2k squared. If we simplify here, we can get that 2b squared is equivalent to 4k squared. If we divide both sides by 2, we can get that b squared is equivalent to 2k squared. And again, we can also use this assumption that b squared is equivalent to 2k squared. Then This means that 2k squared is even. Is even. 2k is even. 2k squared is even. 2k squared is even because k squared is a number. If k squared is any number, and if we multiply, if k squared is an integer, and if we multiply k squared with a 2, we can get an even number. So 2k squared is even. So if 2k squared is even, then b squared is also even. Is also even. Right. If b squared is also even, then if b squared is even, then b is equivalent to 2k. So if b squared is even, then b is equal to 2k. Right. Right, now we have the value of b, that b is equivalent to 2k, and we've also deduced that a is equivalent to, but we can also use another value. Instead of using 2k, we can simply say b is equivalent to 2j, any other number. So if we deduce that a is equivalent to 2k here, we then also say b squared is even and is also equivalent to 2j. Then we can take that equation back, which assumes that square root of 2 is equivalent to a over b. This is equivalent to, what is the value of a is 2k over what is the value of b is 2j. If we cancel here, we can get k over j. So the square root of 2 is equivalent to k over j, which is meaningless. Square root of 2 cannot be written in the form k over j. Hence our assumption that root 2 is rational is wrong. So we have proved by contradiction, because our conclusion, it then shows that root 2 is equivalent to k over j. But from the basic knowledge that we know that a rational number cannot be written in the form k over j. But if we assume that root 2 is rational, it shows that root 2 is equivalent to k over j, which is now a contradictory. So we have proved here. We can leave your answer with a box at the end here. Sorry, my board. That box shows that you have proved is a tombstone, which shows that you have proved the result. That's how, guys, we carry out the proof by contradiction. Let me just quickly summarize everything that I have recently covered in this part. Right. Example, it means prove that root 2 is irrational. Prove that root 2 is irrational. Right. And I've assumed that, let us assume that root 2 is rational. Meaning to say it can be written in the form a over b, where a and b are integers. So root 2 is equivalent to a over b. Squaring both sides, you can get this result. Multiplying both sides by b squared, you can get this result. Right, and this result, at this point now, let us analyze this in detail. 2b squared is equivalent to a squared. You can, if you multiply a number by 2, you can get an even number. So 2b squared is an even number. So if 2b squared is an even number, yet we are saying this is the same as this, this also means that a squared is also even. So if a squared is also even, right, we can go to square numbers. A squared gives us an even number, meaning to say, for us to get an even number, we have to square, a must be even, to such that if we square that a, we can also get even. So we assume that a is also an even number, right? So if a is an even number, this means that a can also be written in the form 2k, right? So if a can be written in the form 2k, we can substitute that result into this equation, which I have written here, that 2b squared is equivalent to a squared, and we've substituted the value of a, which is 2k, at this part to get 2b squared is equivalent to 2k squared, which gives us 4k squared. So if we simplify this, we come up to a point that b squared is equivalent to 2k squared. Again, we have to use that assumption that if 2k squared is even, then b squared is also even. And if b squared is also even, this means that b is an even number, because if b is an even number, if we square it, this is the situation which can only give us an even number. Thus, we relate that if b is an even number, then b is equivalent to 2j. Alright. Given that b is equal to 2j and a is equal to 2k, we can substitute in the original statement that root 2 is equivalent to a over b, which then gives us this result that root 2 is equivalent to k over j. But surely we know that root 2 cannot be written in the form k over j. Then this then means that our assumption that root 2 is a rational number is wrong. Then we have proved by contradiction. Thank you guys. Enjoy. But before we call it a day, let me just leave an exercise for you to do. Right, exercise. Prove that root 5 is irrational. Number 1. Number 2, prove that log 2 base 10 is irrational. That's your exercise. Okay guys, enjoy. We are going to proceed from there looking at proof by induction. Thank you.